Welcome to the course Exploring the Solar System. I am Shweta from Astronera, and in this lecture we will understand how the smaller bodies of the solar system contain important clues about the origin and the evolution of the universe. These smaller objects orbiting the Sun fall into three main categories. First, the asteroids, which are rocky objects found in the inner solar system. Second, the trans-Neptunian objects, which are rocky icy bodies found beyond the orbit of Neptune in the outer solar system. And third, the comets, which are mixture of rock and ice that originates in the outer solar system but can also venture close to the Sun. Let's go through these one by one. Dividing the terrestrial planets from the gaseous giant planets between Mars and Jupiter lies the asteroid belt. Asteroids are minor planets, and scientists estimate that there are more than 750,000 of them with a diameter larger than 1 kilometer and millions of smaller asteroids as well. The dwarf planet Ceres resides here. It has a diameter of about 900 kilometers. Roughly 1/4 of our own moon. A number of asteroids have orbits that take them closer to the solar system, that sometimes lead them to collide with the Earth or the inner planets as well. Such collisions have resulted into meteorite impact craters on the surface of the Earth, such as Lona crater in India. The trans-Neptunian objects, as the name suggests, lie beyond the orbit of the Neptune. Pluto is also part of this group. Its orbit is highly elliptical, and sometimes it can also cross the orbit of the Neptune. But worry not, the orbits of Pluto and Neptune are in such a way that they will never collide onto each other. So far, astronomers have discovered more than 900 trans-Neptunian objects, and each year we discover more and more of them. These objects are way too small to be called as planets, but are bigger than asteroids. Even though they are about 30 astronomical units away from the Sun, most of them revolve around the Sun in the same direction as the other planets. Just as the asteroids lie in the asteroid belt, the trans-Neptunian objects are part of the Kuiper belt. It's about 20 astronomical units wide. Just like asteroids, trans-Neptunian objects are thought to be debris left over from the formation of the solar system. The rocky bodies could sustain the exposure to the heat nearer to the Sun, and the ice which was originally present there would have evaporated. Far away from the Sun, such icy bodies survived in the Kuiper belt. We can say that the debris in the solar system divide into two main families, just like planets: rocky asteroids and partly icy trans-Neptunian objects, arranged according to the distance from the Sun. The Kuiper belt merges into the spherical Oort cloud around our solar system about 50 astronomical units away from the Sun. We have not yet spotted any object in the Oort cloud directly, as it is so far away from us, yet we know a lot of comets that take more than 200 years to orbit the Sun are born there. Short period comets that complete their orbit in less than 200 years are thought to originate from the Kuiper belt. Comets are often known as dirty snowballs and are mainly made up of ice and rock. These are also debris, but unlike the ones in Kuiper belt, those in the Oort cloud do not follow the same direction to orbit the Sun as of the planets. They fly in any direction. Hence, the chance of them colliding onto each other is very high. When this happens, one of the colliding objects can be knocked off and get diverted into an elongated orbit which brings it close to the Sun. That's our comet. When a comet's orbit takes it close to the Sun, some of the ice in its central nucleus turns it into gas and shoots out of it. The solar wind carries it outwards to form a long, beautiful tail. Alright then, now we have gazed all the main elements of our solar system up close. Let's quickly revise them together in the next lecture.